Welcome to Adangal. Good evening to all.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening. Let us study about mirrors. First of all, we will discuss about the plane mirror and then about the spherical mirror. So what is special about the image formed by the plane mirror? So we already know that the image formed by so please check. We have this information. It is erect, virtual, and of the same size, and it is formed at the same distance as the object is in front of the mirror.
Hands laterally inverted.
Yes, that's what I'm about to write. Laterally inverted means left side becomes right side, and vice versa. Vice versa. We can also say that a plane mirror changes right-handed coordinate system to left-handed. For example, suppose this is a mirror, okay? Let us draw a right-handed coordinate system like this. Right-handed means when I use my right hand in order to make a cross product between any two of x, y, z, then I get the third axis or opposite to that one. For example, x cross y, it points in z, and y cross z, it points in x. Z cross x, it gives me y. But after the reflection, this will happen: x dash, z dash, y dash. Now you can see, if you use your left hand in order to make the cross product between x and y, then the thumb points in z. Similarly, y cross z, it gives you x. X cross z, it gives you y. See, am I right?
Yes, sir.
So left-handed coordinate system, it becomes a right-handed or vice versa. Clear?
Yes.
Now, sometimes when you visit in the barber shop, you might have noticed that you see number of images of yours when you are having a haircut or something like that. Have you ever observed that?
Yes, sir. Sir, सामने मेरा पीछे मेरा.
Yes, yes. Why that happens? Nothing was audible. Due to multiple reflections. And those two mirrors, they are normally placed parallel to each other so that there are multiple reflections. Okay. But if the two mirrors, they are inclined at some angle, then we can get the number of images formed by those two mirrors. Now, when two mirrors are inclined, now there is a formula by which we can calculate the number of images. For all positions of object. All position means object can be anywhere if 360 by theta is an even integer. It is equal to 360 by theta minus 1 even when if the object is on the bisector of mirrors. (360 by theta is an odd integer, and it will be equal to 360 by theta if object is not on the bisector of mirrors. And 360 by theta is an odd integer. For even integer, this is the generalized formula. For odd integer, these two are depending upon the position of the object. And what happens if 360 by theta is not an integer? Then what? If 360 by theta is a fraction, suppose, suppose something like 5.2. Okay, then the number of images formed will be 5. Number of images formed are equal to its integral part. Please check. So these formulae you have to remember. Clear? Is it clear?
Yes, sir.
So now let us discuss something about the spherical mirrors and the cases of the image formation. Spherical mirrors. It is also a part of the big sphere, and obviously it is a reflecting surface. It should be hollow, na? And two types of spherical mirrors are there: convex and concave. So first is concave mirror. Okay, when the reflecting surface is towards the center of the sphere, and the second one, in case of convex mirror, the reflecting surface is away. Please check. Let me show you the concave and convex. Let me take the help of the software. That way it will be convenient. Huh? Is the screen visible?
Yes, sir.
Let me insert the shape. Okay, so these are the two spherical mirrors. Now, if this is the polished one, means inner one is reflecting, na? It is concave then. Means this M1, M2 is called the mirror. So a ray of light comes over here. Let me draw the perpendicular from the center, normal from the center. This one. Like this. This is F, this is C, this is P, this is I, this is R. And similarly in this case, so a ray of light comes over here. Like this. Okay. This is the focus. This is I, this is R. Please check. This is incoming one, na? So ये reflect हो गई यहाँ से. Now what is pole? Actually, pole is the midpoint of this curved portion M1, M2. And any section of the mirror is called a principal section. Okay. Now what is center of curvature? This C. It is the center of the spherical portion of which the mirror is a part. Okay. It is the center of the sphere of which the mirror is a part.
So what do you mean by a section of the mirror? Any particular
Part of the
part?
mirror.
Okay.
I have written such as M1, M2. So this is one part of the mirror. It may be this smaller one. It may be this one. Okay. Or it may be this large one. But it should pass through this P. That will be called principal section.
Okay, so got it. Thank you.
Radius of curvature is the radius of the sphere of which the mirror is a part. Principal axis. Principal axis is the line passing through the center of curvature and the pole. And extended on either sides. Aperture. Aperture is the size of the mirror. No? And here in this diagram, we have taken it to be M1, M2. And last is principal focus. It is the point where the parallel rays, after reflection, they meet or they appear to come from this point. In case of concave, they meet at this point, and in case of convex, they appear to come from this focus. No? You can see they are not actually coming at focus, but it appears as if they are coming from the focus. No? Okay.
It's typically a midpoint of radius of curvature, I think.
Yes, yes. Please note. Clear?
Sir, please show the previous slide. Yes, sir.
And last one is the focal length, which is very important for a mirror. It is the distance between the focus and the pole. And is denoted by F. So F is always equal to R by 2, na? Half of the radius of curvature. Okay.
Yes, sir.
Means this lies midway between the center of curvature and the pole. Now there are some sign conventions to be used for the image formation by spherical mirrors. Let me show with the help of the diagram. What are the sign conventions? Point. See, in case of concave mirror, you are taking these parallel rays. Na? If you take another parallel ray, even then it will come at focus. If you take another one, even then it will come at focus. So in this case, they actually, this is called converging rays. These are converging at a single point. Okay.
Yes, sir. मतलब all this F पर conversion.
Yes, तो अभी मैं erase कर रहा हूँ क्योंकि उसमें फिर mix up हो जाएगा.
I got it, sir.
But in this case, when you are taking the rays, they appear to come from focus. They are not actually meeting at focus. They are coming and they are getting reflected. They are coming and they are getting, but all of them they will appear to come from focus. Got it?
Got it.
So this is called diverging rays. No?
Yes,
So
sir.
they are moving outward. Heights above the principal axis they are taken as positive, and downwards they are taken as negative. This is the direction of incident light. So distance in the direction of incident light, they are taken as positive. Distance clear? And all the distances they are measured from the pole. Please note down. And those methods opposite to the direction of incident ray are taken as negative. Same thing I'm writing in the form of points. But if you have understood the diagram, then there is no need.
Yes.
Please check. So I will be straight away writing the formulas, for example, mirror formula and all. We are not going into the derivation at all because they are not to be asked in the exam. So mirror formula, actually it is a relation between the position of the object, image, and the focal length of a lens. Okay. U is the distance of object from the pole. Focal length of the mirror. And this is true for both kind of mirrors, whether it is concave or convex. Means this is a universal mirror formula. Okay.
Okay, sir.
But we will definitely discuss about the magnification. What do you mean by magnification? It is actually the ratio of the size of the image to the size of the object. It is also called a linear magnification.
Yes, sir. I upon equal to yeah.
Yes, it is defined as it is denoted by and generally image is denoted by AB and object is denoted A dash B dash and object is denoted by AB. Now magnification can also tell us about the nature of the image in case of real and inverted. You know that real image is always inverted. So in case
Yes,
of
sir.
real and inverted, magnification is negative because then A dash B dash will be negative and AB is always positive. Object is always erect. And in case of virtual and erect image, it is positive. Clear?
Yes, sir.
Yes, sir.
Now let us discuss few cases in order to get insight into the magnification. Let us discuss the case of concave mirror first. This, no? So this is the case of a real image, a real image by concave mirror. And you can see in this case, what do we have for the magnification? Can you tell me?
Sir, minus हो जाएगा.
Object and image distance both are negative.
Yes, sir.
Yes, sir.
So what we can write? Anyone?
Image size is very small. Magnification is diminished.
A dash B dash is minus O, a minus I, AB is O, PB dash is minus V, PB is minus U. So minus I by O, actually what is the equation? Minus I by O is minus V by minus U. So I by O is minus V by U. These two minus signs got cancelled and I by O is minus V by U. It means the magnification is minus V by U when the image is real. Okay. Actually, this A dash B dash by AB, it should be equal to PB dash by PB. in these two triangles, this one and this one.
Yes, sir.
I have added PC. Okay, and accordingly I'm getting it. Now, when there is a virtual image, then
Positive manipulation.
by a concave mirror. What is that case?
So can I go to view side once? Just one. Okay.
Between P and F, no? Then this is the case. Here. Please check.
Just out of curiosity. So why does all the rays that goes towards the center of the curvature acts like a normal? I mean, incidence as if like incident angle is 0. Same ही path भी trace करता है.
Radius, actually it is the radius one. Radius is always perpendicular. Your spherical surface
Okay.
is the center. No?
C is the center. So every radius is
Yes, that is always perpendicular to the
Okay.
surface.
okay.
Because if you draw any tangent, then it is always perpendicular. No? That's the reason.
Okay, so got it.
Now, what about the magnification?
V by U.
Let me first write A dash B dash is plus I. AB is plus O. PB dash is plus V. PB is minus U. So A dash B dash by AB. PB dash by PB. So I. Okay. But now don't get it wrong that it is coming out to be negative. As your V is positive and U is negative, so this will become positive. Okay. Here definitely it was a negative because V and U both are negative. No? Please check, is it clear? Clear?
So for both the cases, the formula is same.
Yes.
Just the
Now, in case of convex mirror, obviously virtual image is formed. No?
yes, sir.
Can I directly write now or should I make the diagram? Okay, let me make the diagram. Focus, it goes here. And one ray directly passes through C, which is somewhere here. So it goes here and it comes back because this is behind the mirror. No? So here is where you are getting your image and you can see it is virtual. Clear?
Yes, sir.
So A dash B dash is plus I, AB is plus O, PB dash is plus V, PB is minus U. So A dash B dash by AB, PB dash by PB. So again positive. Please check. So in all the cases, the formula for the magnification is minus V by U. Okay, but it may be negative or positive, and it may be greater than 1 or less than 1. For the magnified images, it is greater than 1, and for the diminished one, generally which are real, okay? The real images are the diminished one, and the virtual, sometimes virtual is also diminished one, as is the case of convex one. But in case of concave, it is other way around. Okay, got it?
Sir, and to negative another positive. sir.
कैसे negative आया? Can you explain me? How can you say it is negative?
Okay, sir. Okay. You be negative हो जाएगा.
Yes, V is positive, U is negative. So negative will get cancelled, it will be positive. No?
Okay, sir.
So now there are two more formulae for the magnification in terms of the focal length and U or focal length and V. We know that 1 by u plus 1 by v is 1 by f. This is the formula for the magnification. Please check. And similarly, we can multiply by u instead of v. Then we can get another formula in terms of f and u. This one.
So please show previous slide. Okay, sir.
Done?
Yes, sir.
Yes, sir.
Now let us discuss various cases of image formation by concave mirror, and then you have to remember the results. And same results, they will help you while studying the lenses. So first case is at infinity. When the object is at infinity, then the image is formed at the focus. This. Okay, you can see these are the rays from infinity because the object is placed at infinity, na? And they are meeting at the principal focus. So image is getting formed at the focus. Na?
Yes, sir.
So image is real and it will be inverted at f. And of course, very, very small, almost point size. Clear?
Yes, sir.
Second case. Now we keep on moving the object towards the pole, and we will see that there will be a shift in the position of the image. As the object is moving nearer to the mirror, the image starts shifting away from the mirror. So now it was formed at the focus, and in the second case, you will find that it will form between f and c. Object is between infinity and c. So the object is somewhere here. You can see the image is formed here like this. Okay, so again, real, inverted, diminished, and between f and c. Na? Is it
Yes,
clear? So you can see the image has moved away from the mirror, na, by some distance. Earlier it was at focus, and now when we take the object and see, the image will also be formed at c. This one, it should be actually, this ray has bent somewhat. Na? Now it is okay. So it is AB, you can see, it is B dash A dash. So again, real, inverted, same size as that of object at C. Okay. So now the object should be between F and C, and the image will be beyond C. And now the size of the image will also increase. Size is increasing slowly. Now it has become equal, and in the next case it will be magnified. So suppose the object is lying here. This now, and you can see it is beyond C and magnified now. Will it be real or imaginary?
Real.
Yes. So actually for that to observe, this image should be somewhat bigger so that I can show you that this is real. But that is quite a difficult task for me now. Let me see where this ray is actually going. So this ray is going here. So this is what is happening. This is going towards some mirror and it is getting reflected back. And then that's when it is meeting. Okay. Real, inverted, magnified, or enlarged. Beyond C. Or between C and infinity, you can write. Beyond C means anywhere between C and infinity. Clear? And
Yes.
now we can place the object at F and between P and F. We are left with two cases. Now the image will be formed at infinity. You can see these rays are parallel and they will actually meet at infinity. So it will be real. So when the image will form at infinity, it will be highly magnified. Very large. Okay. Done.
Yes, sir.
Yes, sir.
Last case between F and P. And this is the special case for concave mirror. Because only in this one case we get
Virtual image.
yes, virtual image. Otherwise, you have seen in all the cases we were getting real image. So is there any practical use of this case?
Yes, sir. Magnified glass.
Magnified glass. Okay. But that is a
For
lens.
shaving.
Yes, shaving mirror. Magnified glass is a lens. That is not a mirror. Please check. Virtual, erect, magnified, behind the mirror. Clear?
Yes, sir.
And what are the cases in case of convex mirror?
So only two cases. Object infinity and then every case would be virtual.
Yes. So image formation by convex mirror. Clear?
Yes, sir.
So it is virtual, erect, very, very small, at focus. Clear?
Yes, sir.
Obviously, the object will be to the left of the mirror, and the focus and the center of curvature are to the right. So there will be one more case when the object lies in front of the mirror, not at infinity. Means at a finite distance from the mirror. Between P and F. Please check. Clear?
Yes, sir.
So let us discuss few numerical problems. I will start with the easiest one. The focal length of a concave mirror, 30 centimeter. Magnification is given. Image is 3 times the size of the object. Image is 3 times the size. So in case of concave mirror, what we have? See here. When we go back, in case of concave mirror, try to observe it. No, Durga. No, Satish. Okay, Durga, you are telling me the final answer. Actually, there will be two cases. Na? That's what I have shown you. So you have to assume if the image is real and if the image is virtual. Because there will be two cases for magnification. Na? Of course, your answer is correct for one of the cases.
For real image.
No, for virtual. If the image is real and inverted, then magnification will be taken as -3. Na? Otherwise, the formula is -3 by u. But you are taking the image as real and inverted, so this 3, it means it will be -3. Na? So according to mirror formula, this becomes 1 by u, 1 by 3u, 1 by -30. So this gives us 4 by 3u minus 1 by 30. So u is equal to 4 into 30 by 3 minus 40. Na? Okay.
Minus suggests that it's on the left hand side, right?
Yes.
Okay.
Should be placed. It means in front of the mirror. Otherwise, we will say it at the back of the mirror or behind the mirror if we are getting it to be positive. That's what the nomenclature that is generally used. Now, case 2, if the image is virtual and erect. If the image is virtual and erect. Now it will be 3. V will be minus 3u. Okay. So these are the two possibilities. Clear? Is it clear?
Yes, sir.
Yes, sir.
So it is concave mirror. No? Now first case. U is 10. No? So from mirror formula. So the image is formed at a distance 30 centimeters. So in this case, the magnification will be. So hence, because magnification is negative, image is real and inverted. And 3 times the size of the object. Okay. Second, 5 centimeter in front of the mirror. Second part means u is minus 5. So now if I make use of mirror formula, hence the image is virtual, erect, and 3 times the size of the object. Clear? Please check.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, previous slide one.
Akash, you can drop a message in your group, whatever group is there, and you can have a talk with the technical team regarding that. Yeah, someone was saying something in the previous slide.
Yes, sir. Yes. Okay, sir. Okay.
So that's all for today, students. Okay, bye bye. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.